You can say that this is more or less not new for the construction industry. With geosynthetics, you can fulfill all or mainly these requirements, and we will see this within the next slides. But before starting with sustainability overall, we have to have a closer look in what is an LCA. An LCA always looks in the full product life cycle and compares different product life cycles or construction. That means you do not look for only one single product and look for the production and then stop when you supply it. You look for the whole construction, you look for the whole production, getting the raw material, and then you compare these with others. For example, you can see here it started with the extraction, and in the early days of LCAs, and that was also the case in the early ones that we have done with the EAGM, it ends with the use of the material. With the newer ones that are just under preparation and will coming in the next years, it goes a bit further until the moment when you recycle these products, or if recycling is not possible, if you put it into waste. LCA looks over different or in different aspects. The energy, the resource, what happens with climate change, what is with ecological, and also the human health is an issue for an LCA. And these can be one of the main parts of the sustainability analysis. If you see the LCA, there are some main evaluated impact categories, and that, for example, is done also with the LCAs that are done by the EAGM. It's mainly looking for 9 impact categories. You can see them here: greenhouse gas emission, particulate matter formation, what means, what are effects that cause, for example, damages in the personal, for example, if you get problems with your lungs and so on, if you have gases. The summer smog eutrophication, that is a part of the pollution in the nature, similar with acidification. Land use is a part where you can see it in 2 different ways. One way is that you only compare 1 square meter to 1 square meter, for example, in a road, or you can also do it in the way that you identify if there are some impacts on the biodiversity, and then in these cases sometimes the difference, especially with LCAs in construction, are different in using of the land use. Then we have the abiotic resource depletion. That means something like, for example, coming from gas. And you have the accumulated energy demand based on the non-renewable and also on the renewable. So for today, we have some examples a little bit more in the details. We have the 4 LCA cases that are done in the EAGM in 2009 to 2011 and that are renewed in 2019. We have a very nice case from ABG, from David Shercliffe, that was presented first time in 2019. We have then 2 cases that are done by Naue, and also a new thing coming from Husker, where I will go a little bit more in the details. And then we have also some more where I only like to highlight these, that there are more examples, and you can find also literature for this. For example, like circular economy, biopolymers, other LCAs, and for example, also one thing that is done in the UK in 2010 under the name or the letters of REP. So let's start with the case 1 that we did with the EAGM. In that case 1, there was a comparison of a filter system below a road, and we compare in that case what are the impacts if you will install a road with a gravel or granular filter and compare it with a geosynthetic filter. You can see here really the differences. In the upper part, we have a granular filter with roughly 30 centimeters. And in the lower part, we took a more or less standard geotextiles that can be used in these kind of applications, PP non-woven with 175 gram per square meter. And the main thing of these LCA was to analyze only the differences. So all the things that are done by exactly the same way in both cases are not part of the LCA. That's also not part of the other LCAs. It is always on only a closer look in where you have differences between one and the other case. Finally, you can say after evaluation of all these details, as I said in the beginning, from getting the raw materials, for example, in case of the polypropylene non-woven, getting the oil for producing the raw materials, the granulars, the fibers, and so on, or alternatively getting the gravel to the site. After the evaluation of these 9 impact categories, you can see here the summarize of all the results, and you can see with the second column always the amount of impact in comparison to the others in the first column, where in the first column is the gravel filter and in the second column is the geosynthetic filter. What you can see here clearly is that the impact with construction with a geosynthetic in direct comparison is always less than 30% of the impacts with the gravel. So to summarize a bit, the case 1 is we have a much lower environmental impact for all categories. And for example, if you go especially into the cumulative energy demand and the CO2 emissions, we can say we have always less than 20% of what we would have if we install or if we make the construction with gravel. If you go to the second case, that's a stabilized road, where we have the comparison in 3 ways. One is the change of more sub-base material. The second part was installing a geogrid or a geosynthetic. And the third part is a stabilization of the soil with lime or with cement. Here you can also see directly the differences in the height of material that has to be changed or which we have to work on. And okay, these columns are a little bit more, and you have to have a closer look for this. If you compare the classic construction where you have a more sub-base material instead of using the geosynthetic, you can see that the number with the geosynthetic is always lower. If you compare it with cement and lime, you can see that is in average is more or less similar what you can see as a result. But if you go into the details with, again, cumulated energy demand and CO2 emissions, you can see that also here the level is a bit lower, but this depends clearly on the detailed construction and also on transportation ways, sorry. The third case that is done in the EAGM was a landfill drainage comparison, where it was compared what happened or what are the impact categories if you compare a geosynthetic drainage layer with a gravel drainage layer. So we took the European landfill regulation and compared these. And again, here we have only the drainage layer compared. We do not compare, for example, the filter layer on top of the drainage layer or the protection layer below the drainage layer, because this is in both cases the same. And if you compare these results here, we have, again, as in case 1, higher difference between the classic construction with the gravel material in comparison to the geosynthetic material. And if you see these, for example, in case of the accumulated energy demand and the CO2, we have a reduction with the construction with the geosynthetic of 55 or 70%. Coming to the last case that we have in the EAGM worked on is the slope retaining structure. In one case with a concrete wall, and in the other case with a geosynthetic reinforcement. For the geosynthetic reinforcement, we took as average over the industry a geosynthetic with a long-term design strength of 14 kilonewton per meter. And here's a typical or several typical pictures of the surface that we could have typically for a retaining wall with a concrete or with a geosynthetic as reinforcement behind the surface. And here again, you can see a big difference between the construction with the geosynthetic or with the classic construction, in that case with concrete, where you have in most of the cases less than 70% or you have more than 70% reduction of the impacts with the geosynthetic. And again, especially with the cumulative energy demand, you have a reduction of 75% and you have 85% reduction of the carbon footprint. So in summary, you can see, you can say that the geosynthetic can significantly reduce the impacts or most or nearly all of the impacts that you have in a construction for the 9 impact categories. And there's one main thing that you have to know. We speak about an LCA, and you might have heard also from environmental product declarations. That is something that some of the producers have for the products, and they are sometimes used on site. And an environmental product declaration is very helpful to do such an LCA, because many of the data you need for an LCA that is specially done for a project is in these environmental product declaration, but an environmental product declaration alone could not solve these questions. You really have to compare the constructions and not the products, for example, based only on an environmental product declaration. More details of these studies that we have done as the EAGM, you can see them on the webpage of the EAGM, and there are also several presentations out, for example, at the EuroGeo 5 or also at the IGS conference in Berlin that was done from one of the persons that did this LCA for the EAGM. So coming now to another example that is not done by the EAGM, that is done by a producer of products. It was from ABG. This was presented from David in November 2019 at an IGS session in Prague. And here he demonstrated or showed the differences between 2 possible drainage materials in the construction of a highway. You can see here it is a highway in UK from Huntington to Cambridge. And originally there was a request to install a hollow block system, a concrete hollow block system as the drainage on these materials. And there was a very nice thing done at this project, because there was a request to all the people to give a calculation or to have an environmental impact statement regarding possible alternatives, how you can save CO2 emissions for these projects. So the owner was very open to get alternatives, and this was mainly done by impact statements. So here you can see, for example, one of the bridges. And this, for example, is a bridge or a road that was or will be constructed to save traveling time. And also reduce traffic jam that you had in the past each day. So when this is finalized, I do not know if it's finalized today, but then this will save many traffic jams and traveling time. And as I said in the beginning, originally the tender was asking for a back of wall drainage with these hollow blocks. And you can see here, for example, the typical questions that are with these materials. You have maybe some problems with heavy transport to site and also on site. You need many trucks traveling to this site. And for example, to produce these concrete balls, you have high use of natural resources, as you can see on the upper part of this slide, and also these many trucks giving problems to the public authority and damaging existing roads. If you see in comparison to that, the drainage walls, the plastic wall drains, you can see here the principle of this material with a filter and with a drainage. And you can see what is one of the big benefits. So if you have to transport all the material, all the block walls to site, you can see here how many trucks you need for the transportation of the blocks on the one hand, and on the other hand, how many trucks you need for the infill and the stones. And with the same quantity of surface that you can that you would use for the drainage, here you can see it is only one truck to transport the material, the drainage material to site. This is the transportation to site. And you have also similar questions when you have transportation on site. For example, if you have 550 of these blocks, you can use the same surface, or you can drain the same surface with only one of these rolls. And all this has to be transported and also installed at site. One thing that was also done by these evaluation or by these request from the owner is that there was a carbon footprint calculation, and for that it was the system REP was used. REP is something that was developed roughly in 2010 in the UK and is a base for calculations of LCAs on site and give you some numbers and also some guidance how to calculate this. And if you calculate these, for example, for the hollow block system, and also you did it similar or in the correct way for the geosynthetic drain, you get at the end a reduction of CO2 emissions with the geocomposite of roughly 91%. And for example, if you see these 91%, what does it mean? There's a very nice example from David. He said, okay, if you do this, you will save with these the CO2 emissions of 53 round trips via plane from London to Amsterdam and back, or alternatively to store these CO2 emissions, how many ash trees you would need. And I think this example clearly shows very good how much CO2 emissions can be saved with the construction with a geosynthetic in that case. One other example from an hydraulic application is a score protection, also something that was built and in difference to what we did in the EAGM. In the EAGM, we took general or average values over the whole industry and also over whole Europe with different constructions. Here in that case, we see an example that was really built in the North Sea, an offshore wind park Amrum Bank West. And originally, the tender requires a conventional rock system And the alternative solution was to make the scar protection instead of with rocks and sand, to do it with geosynthetic sand containers. And not only the geosynthetic sand containers as they are installed in Amrumbank West and the tendered version was compared, there were also two other offshore wind parks like Rampion and Rifgard, also part of these comparison. So to show you shortly what was done in the scar protection, on this slide you can see the classic way of construction, scar protection for an offshore wind park. You can see here on this slide the installation of the first part of the monopile. Then here you see the scar protection, no, sorry, mistake. Here you see the first part of the construction of the monopile. Then you can see here the construction of the scar protection. The problem might be here that during the installation phase, the rocks can damage the monopile. And here you can see the final stage where also the full monopile was installed. Alternatively, you can do this with geosynthetic sand containers. Here, in that case, the procedure is a little bit different. You install first the scar protection, then you install the monopile. Without damaging the monopile, you can push it through the scar protection and can finalize then the monopile. In this comparison, there was a comparison of the whole production of the geosynthetic sand containers with all the raw materials, the sand filling, the installation of the geosynthetic sand containers, and the operation and end of life was, in this case, calculated with the end of use after 25 years. And in comparison to that, there was the mining of the gravel of the rock, the installation, the operation, and then the same end of life. The end of life, as I said, was expected after 25 years. In both cases, there's no maintenance. And there is, after 25 years, the end of life. If you compare these results, we can see here with the first column, the blue column, always the results with the geosynthetic sand containers. And then you can see with the next column, the orange one, the Amrumbank West, that was the tendered version from Amrumbank West. This is always, the column is always given to 100%. And further on, you can see the calculation with rock Rampion, where the scar protection is a little bit thicker than in Amrumbank West. And you can see also rock Rifgard, where it's a little bit lower than in Amrumbank West. And you can see that in all cases, we have a very high reduction of all the impact categories in comparison between the geosynthetic sand containers and the solution with the sand and the rocks. And you have to have in mind what is not here part of the LCA is the calculation or the loss of the natural resources, because, for example, you have to take all these rocks from Norway via ship. The next comparison is the calculation or the comparison between a compacted clay liner and a GCL. I have to say that for the following comparisons, these are mainly done for carbon footprint and cumulated energy demand, or for example, also for the cost comparison. It's not more done for all the 9 impact categories as we've seen with the cases before, but the results are more or less the same. If you install a compacted clay liner, you have to have in mind what all has to be done to install it in the correct way. You can see here highlighted a bit all the different stadiums that you need to install a compacted clay liner in the correct way. And on this slide, you can see more or less how easy it's in comparison to install a GCL to that. And one thing you must have in mind is how much water is needed for a compacted clay liner. I think that's not everybody have in mind, but to install a compacted clay liner, you need the exact and right amount of water depending on the compacted clay liner to have it in the right density. And for example, for an area of 40,000 square meter with a thickness of 0.5 meter, you need 2,300 cubic meter of water for the installation process. And this is a very big amount of water, especially if you see how many water we really have on the Earth. You can see here our Earth. You can see how many water we have on the Earth. Sorry. This is this dot. You can see here with a very, very small dot how much fresh water we have. And there's also one more smaller point. That is the fresh water where we have a connection to, where we can get from nature directly. So the water that we have is also a source that is reasonable to save. What you also should have in mind is if you install instead of a compacted clay liner, a GCL, you can have much more waste in a landfill with the same cubature because you save roughly 49% on top of the landfill and no, not percent, centimeter, and 49 centimeter on the bottom of the landfill, and you can use or install in that way much more waste in the same landfill. If you look for the CO2 emissions, you can imagine that only the transportation here, in that case, you can have on one truck roughly 4,000 square meter of a GCL. And for 4,500 square meters with clay, you need such an amount of trucks. So similar to the examples that we had before, for example, from ABG, you have also to have these in mind, how many impacts these have, for example, on the nature and on the people living around construction. If you calculate the cumulated energy demand, for example, for a landfill cap with 36,000 square meter, you will find a reduction of roughly 40% of CO2 emission, of accumulated energy demand. And if you compare these, for example, for the CO2 emissions, you have roughly 60% less CO2 emissions when you use, instead of compacted clay liner, a GCL. So to summarize this, with a GCL, you have you save many water, so you save your natural resources. You save also the clay that you do not have to use in the landfill. You can put much more waste into a landfill, and you save a huge amount of CO2 and energy demand in a direct comparison. And you can see here again the difference between carbon footprint and energy demand in these two constructions. Sustainability is not only an LCA, it's also save resources, natural resources, but also other resources. And these, for example, was one thing that was maybe the idea for creating new products. You can see here this product from Hyska. It's called Ecoline. And this product is a reinforced polyester material from recycled PET. And why these? It's coming maybe from the idea that is published in 2017 from the European Commission. And at the end, it is a big discussion that we have actually in the industry following the approach of circular economy, where we should have in future more and more use of recycled material and the possibility also to recycle this material. In this case, you can see, for example, from bottles, in that case from shredded bottles, PET bottles, to regrind this material, and also with the polymerization of this material to install or to produce a granular that can be used similar as a virgin material with similar characteristics, as you can, for example, see here. These are the results from a polyester filament, one produced from virgin material, one produced from recycled material, and in that case, the hydrolysis is tested, and you can see that it's more or less same result. In that case, for example, the recycled material has a slightly better result than the virgin material. So reinforcement is also something that, not reinforcement, recycling is also something that has to do with sustainability. And in that case, it's not only sustainability, it's also a reproducible quality. And also with these kind of productions, you can reduce the CO2 emissions because this material can be used and can recycled. For example, if you see these values, with these you can reduce the CO2 amount that is needed or that is produced during a production for a quantity that is, for example, the same as a football pitch. You can reduce the CO2 emissions in such an amount as you, for example, will produce with a car where you travel 40,000 kilometers. One more example going in a similar way is that recycled polyester is also used in Australia for the productions of nonwovens. So a little bit different to what is done here in Germany with a reinforcement product, but in principle, it looks similar. So in that case, the producer has two new product ranges. One is the BDIM Green, and this is a recycled Australian plastic bottles, or it's the eco material where it could be all kind of polyester bottles as the basis. At the end, it will be also recycled, maybe condensate, and then used as raw material for fiber production. What you should have in mind is that sometimes these kind of products are a little bit more expensive than the classic materials because the recycling process actually is a bit more expensive. But if you see it from the ecological side, these products have definitely benefits. One other thing that is also, that has also to do with sustainability is the use of natural resources for fibers, or let me say biopolymers. You can see here 4 different grades of materials. You see the blue one that is a fossil-based material and not biodegradable. And then you can see the green ones that are more or less named under the umbrella of biopolymers with different values. Sometimes they are bio-based and biodegradable, or they are biodegradable but fossil-based, or bio-based and not biodegradable. And there's also a new product available that called Secotex Green. For example, the Green G1 is a bio-based and biodegradable material. And in comparison to other materials in the past, this is a material that is really produced from industrial produced natural fibers. So there are sources behind that always produce the regular fiber with a very, very low variation. And you can produce quite good and reproducible materials. And if you see these then in the whole way of production until dismantling or industrial composting, biological degradation, you have with these kind of products new possibilities depending on the application and where you have to use these kind of products. So they have some benefits, and these parts are new and definitely also sustainable. If you look a little bit around the world, you found also some other examples where you see comparison between different materials that can be used in construction. So we had a few minutes ago the comparison between a compacted clay and a GCL here. In that case, that was an example from last year from the Geo-America, where some colleague present some summarize for the comparison of a geomembrane versus a clay that was done from Sotrafa. And here you can see, for example, the two construction technologies. You have on the left side the compacted clay liner, on the right side you have the geomembrane, and you can see also the numbers of CO2 emissions that were produced by installing and producing the materials for 10,000 square meter. And you see that there's a roughly 30% with a geomembrane from what is with a compacted clay liner. And you have also some other benefits with a geomembrane, for example, that the material will last longer. The installation procedure is much easier. And therefore you see that also these have some comparisons between classic construction and construction with geosynthetics. Only one slide. I think most of the people from the UK will know this, and I have mentioned that before with a presentation from David Shercliffe from ABG. In the UK, there was done in 2010 a study how to calculate and what you need to prepare such an LCA, and this study is very useful and available, and you can download it in the net in the UK. Some presentation also similar to the case 4 that we have from the EAGM, but in that case also calculated on a site that was really built in such way. Here in that case, the tender was with concrete and built with it was built at the end with reinforcing material. And here we have done a comparison of the CO2 and the energy demand, and also that is different to all the others that we saw before. We have here in that case also a cost comparison. And let's start with the cost comparison. You can see here the two constructions, the concrete wall or the reinforced wall. And here you can see the cost comparison. So at the end, it was built with the reinforcing product. And due to that, the costs of the whole construction were more or less only 50% to what was originally in the tender. And the save of money was here 260,000 euro. And if you see in comparison to the costs, the accumulated energy demand, we have a reduction of 70% with the reinforced material, and in case of the CO2, we save 80% of the CO2 emissions in comparison to the concrete wall that was originally in the tender. Here you can see also again the three comparisons to that. A last example that I want to show is something that was done in Germany by the German Association IGS. They did a similar study to what was done with the EAGM in case 2. And also here you can see that there is a reduction of CO2 emissions and also on cumulated energy demand in comparison to the construction of a road between geosynthetic on the one hand and lime stabilized on the other hand. Very nicely, yesterday we just had the presentation in Brussels, where you can say more or less our answers could be not more in time as these days. And in this, what was yesterday presented or decided in Brussels is that there's an ambitious climate target for 2030, the reduction of 55% in comparison to 1990. So this is not only, or now it is also a part of the law. And for 2050, that Europe should be the first continent with a negative emission. If you see, for example, what Mrs. von der Leyen said is that she really sees this as a big goal for the next years or for the next decades, and a big benefit for the next generations. And similar, it was more or less done by the Vice President, Mr. Timmermans. And I show these only to bring in your mind that these topics that we saw the last 40 minutes are really a topic actually, and really exactly for these days. So if we conclude what I just have presented, you can say that we have shown examples for different that show different benefits with constructions with geosynthetics. For example, you save CO2 and many other emissions. You have a save of natural resources. You reduce the energy demand. You can use, you can save fresh water with geosynthetics. You can reduce the construction costs, and you reduce the impacts for residents near constructions. So geosynthetics are a part of the solution for the questions that are coming to us within the next years and decades. And it's not new, but it shall be more recognized that geosynthetics are really convenient products that improve all these ecological and economical tasks for the future, and a big part of sustainable products or sustainable use. And to show this, or to say this to you, the IGS has founded last year a sustainability working group and working strongly on these issues. And also, sorry, the EAGM worked on these. The EAGM has also started new LCAs. As I said in the beginning, in the past, the LCAs has always stopped when the products have installed. And for the near future, we will also prepare LCAs where also the dismantling and then recycling or whatever will be part of the LCA. So this is the end of my presentation. If you have some questions, we can talk now. And yeah, that's from my side.
Thank you, Henning. Yeah, if anyone has any questions, I've got nothing posted in the chat. But if anyone has any questions, I'd like to show a hand and we can go to you and unmute you. So I believe Tom Sangster has a question. Ali Razor, can you just unmute? Cannot get that.
Yeah.
Okay.
Time isn't on. Yeah.
Hello, can you hear me?
I can hear you, yes, Tom.
Good. Henning, hello. Thank you for a great presentation. You mentioned the beginning of use of recycled polymers now. You gave a couple of very good examples. How much is the penetration of recycled polymers into geosynthetic manufacture generally, do you think? Are we talking just a couple of %, or is it gaining more momentum than that?
I would say actually the use of recycled polymer is not a big number, but I personally think it will increase within the next years. We have a problem in Europe because, for example, the CE requirements require that you can use recycled polymers or recycled materials from other waste streams only when you give a lifetime of less than 5 years, what in most of the cases is not acceptable. On the other hand, you must see that this definition is roughly 10, 15 years old. And I think the industry has made much developments where, for example, with also these recycled materials, it is now possible to achieve also with this much, much higher lifetimes. The point is only that we are not able to change these in, for example, in Europe in the CE standards today.
Okay, thank you.
Hello.
Hello.
Hi there. Great presentation, and thank you very much. And I've also read your other paper on this as well too. I was just really struck by the value of the comparative study of the geosynthetic solutions versus rock or concrete. And this is separate from your basic LCA analysis or proposal. Is that correct?
You mean the score protection?
Yeah, when you're basically going category by category and comparing, geosynthetic versus, basic rock or concrete. I know the LCA is not comparative; it's more just kind of analyzing the embodied emissions and whatever else. So I'm definitely interested in the comparative study for other products as well too. I think it's a really great tool.
Okay. So I'm not 100% sure that I get your question. I think, as I said, there's more work ongoing. There will be more done in the near future. IGS will do something, also EAGM, and maybe also others will do, and we will get more information and more results to that, and all these will be published.
Right. So the comparative, I guess my point is the comparative study is separate from the LCA. So it's something that IGS also offers in addition to the LCA.
No, the comparative is the LCA.
Oh, okay. All right. Thank you.
Okay.
Okay, so I think if there's no more questions, we'll wrap that up for this evening. I'd like to thank Henning for a great presentation. Hello.
Yeah, Andy, one moment, maybe to the last sentence to what we just had, to make this sure that everybody understood this. The LCA is the comparison of different constructions, and for these different constructions you need for example, an environmental product declaration, or you have to evaluate all these values by yourself. But these LCAs could be really different from site to site, and therefore it's more and more needed that we do these things, maybe not on each site, but on more sites. And this should be requested, and maybe in future also a basis for a decision for this or that solution in the future.
Thanks, Henning. Okay, well, thanks everyone for joining us this evening. You can see the next events that are coming up. We will get this recording available on our website, and it will be recorded for that. So yeah, wish everybody a good evening, good morning, or good afternoon. Thanks very much, guys.
Thank you, Henning. Bye for now.
Thanks.
Andy, I think you can stop the recording now.